Good evening, students. We will start with the class. Today it is last class for the electrostatic potential and the capacitance. So let us start. The last class we have covered some questions. Let's see where we have stopped and we will start it. Okay, just see if any question is repeating, I think this is we have completed. Okay, I think this question from here we need to continue. I don't think so. This question is completed in the last class. So that is repeat agidre ನೀವು ಹೇಳಬಹುದು. You have a particle of mass 1 gram and charge 1 microcoulomb is held at rest on a frictionless horizontal surface at a distance 1 meter from a fixed charge 2 millicoulomb. If the particle is released, it will be repelled. The speed of the particle when it is at a distance of 10 meter from a fixed charge is. Hope so it is not repeated. This solution I'll continue. Okay. So see, according to the figure, so after solving half, you don't tell, it is completed. So check your book. Okay, students, see, that is you have a point charge. So the charge is there and a particle of mass 1 gram. So this particle of 1 gram, I'll consider on this horizontal line at this point. So this mass is 1 gram and its charge is coulomb. So this is on a horizontal line and you have one more fixed charge. Its value is 2 millicoulomb. Its value is 2 millicoulomb and this is at a distance of 1 meter anta ಹೇಳ್ತಾರೆ. This is at a distance of 1 meter. If the particle is released, so ಈ particle ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು, this particle is released ಅಂದ್ರೆ ಇದು ಇಲ್ಲಿ ಏನ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇತ್ತಲ್ಲ ಈ particle ಅನ್ನ ಬಿಡ್ತಾ ಇದೀವಿ. It will be repelled. So ಇದೇನಾಗ್ತಾ ಇದೆ, this particle is repelled by this charge. Okay. So repel agi, so obviously repel adag yav direction al hogutte, ee direction al move agutte. So with what velocity it is moving, but it is covering the distance of 10 meter. Question artha aita? Question is clear? Okay, so at the center ant nan helalla. So one point alli 1 gram body particle is the charge 1 microcoulomb anta heltidare. So one more fixed charge is there at a distance of 1 meter. Now, ee kade kuda tagobodu, ee kade kuda tagobodu. So after repulsion, idain particle ide illi 1 gram particle, it is start moving. Repulsion move agta ide andre ee direction alli move agta ide. So ee total distance is ಎಷ್ಟು cover ಮಾಡ್ತಾ ಇದೆ from the point to 2 millicoulomb charge in the 10 meter distance cover ಮಾಡ್ತಾ ಇದೆ. Okay, with what speed it is moving ಅಂತ question ಕೇಳ್ತಾ ಇದ್ದಾರೆ. I hope the question is clear to you. I'll go for the solution. Okay, if any doubt is there, you can tell me in between also. So see, we are using the conservation of energy principle. So conservation energy principle prakara, that is the Coulomb force between the charge Q1 and Q upon the distance R1 is equal to 1 upon 4 pi epsilon naught Q1 into Q divided by R2 plus the particle ಏನಾಗ್ತಾ ಇದೆ, it is moving with a velocity, that is kinetic energy, half mv square. So ಇದೇನು ಇದೆ energy before the motion. So ಇದು first ಇಲ್ಲಿ ನಾನು 1/4 epsilon naught q1 into q upon r1 ಏನ್ ಬರಿತಾ ಇದ್ದೀನಿ. This is energy in the beginning. So after the repulsion ನಂತರ ಏನ್ ಎನರ್ಜಿ ಬರಿತಾ ಇದ್ದೀನಿ. So 1/4 epsilon naught q1 into q by r2 is the energy of that. Plus ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ kinetic energy is associated with that. ಸೊ ನಮ್ಗೆ ವೆಲಾಸಿಟಿ ಬೇಕಾಗಿದೆ ಹೌದಾ. ಸೊ ನಾವೀಗ ಏನ್ ಮಾಡ್ಬೇಕು, ಈ ಈಕ್ವೇಶನ್ ವೆಲಾಸಿಟಿ ಟರ್ಮ್ ಒಂದ್ ಕಡೆ ಇಟ್ಟು ಬಾಕಿದನ್ನೆಲ್ಲ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ. ಸೊ ನಾನೀಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಹಾಫ್ mv ಸ್ಕ್ವೇರ್ ಇಲ್ಲೇ ಇಟ್ಕೊಂತೀನಿ. ಟ್ರಾನ್ಸ್ಫರ್ ದಿಸ್ 1/4 epsilon naught q1 into q by r2. ಸೊ ಇಫ್ ಐ ಟ್ರಾನ್ಸ್ಫರ್ ಸಿ ಏನಾಗುತ್ತೆ, 1/4 epsilon naught q1 into q upon r1 minus 1/4 epsilon naught q1 into q upon r2. So what is common? 1/4 epsilon naught is common. q1 into q ಕೂಡ ಕಾಮನ್ ಇದೆ. ಸೊ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಏನು ಉಳಿಯುತ್ತೆ ನೋಡಿ. ಸೊ ಇಟ್ ಇಸ್ 1/4 epsilon naught q1 into q inside the bracket 1/r1 minus 1/r2 ಅಂತ ಉಳಿಯುತ್ತೆ. So this is equal to what? Half mv square. So ಯಾರಿಗೆ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಕ್ವಿಕ್ ಇದ್ದೀರಾ, you can continue with the solution. So we can substitute all the values. Let us simplify this. So see, I'll write here. ನಾನು diagram ಇಲ್ಲಿ erase ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Okay. So now simplification. So whoever knows the solution, you can continue. See, 1/4 epsilon naught 9 into 10 raised to 9. q1 into q. So q1 into q ಒಂದು 1 ಮೈಕ್ರೋಕೂಲಮ್ ಅಂತ ಇದೆ, ಮತ್ತೊಂದು 2 ಮಿಲಿಕೂಲಮ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, ಹೌದಾ. ಸೊ ಇಟ್ ಇಸ್ 2 ಮಿಲಿಕೂಲಮ್ ಅಂದ್ರೆ 2 into 10 raised to minus 3, then 1 into 10 raised to minus 6 inside the bracket 1 divided by r1. So r1 is 1 minus 1 divided by r2. r2 is 10. So this is equal to, so 9 into 2, 9 2s are 18, 10 raised to ಇದು -3 -6 -9 ಆಗುತ್ತೆ, plus 9 into -9 cancel ಆಗುತ್ತೆ. So inside the bracket, so 1 by 1 minus 1 by 10. So LCM will be 10. So if I simplify, I'll get it as 9 divided by 10. Correct? So this is what half mv square is equal to. So half mv square is equal to ನನಗೆ ಇದು ಸಿಗ್ತಾ ಇದೆ. Therefore v square is equal to, so v square is equal to half ಅಂದ್ರೆ ಈ ಕಡೆ ಬಂದಾಗ 2 into 18 into 9 upon mass ಎಷ್ಟು ಹೇಳಿದಾರೆ ನೋಡಿ, 1 ಗ್ರಾಮ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಕೆಜಿ ಅಲ್ಲಿ ಮಾಡಿದಾಗ 10 raised to minus 3 ಆಗತ್ತೆ into 10. I hope you are understanding the solution. ಯಾರಿಗೂ ಆನ್ಸರ್ ಬರ್ಲಿಲ್ಲ? Yes. So 18 into 2. 18 into 2 is 36 into just minus to 10 to 1. So 10 raised to minus 3 into 10 raised to 1 is 10 raised to minus 2. ಮೇಲ್ಗಡೆ ಹೋದಾಗ 10 raised to 2 ಆಗುತ್ತೆ. 9 into 10 raised to 2 ಅಂದ್ರೆ 900. So 36 into 900. So 36 into 900 ಇದು ಎದಕ್ಕೆ ಬಂದಿದೆ? v square is equal to ಬಂದಿದೆ. ಆಯ್ತಾ? This is v square is equal to, therefore v is equal to, so 36 square root ಹೊರಗಡೆ ತೆಗೆದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? under root full. ಆಯ್ತಾ? So 36 is root, that is 6. Then 900 ಇದ್ದು it is 30. So what is that? 30 into 6 or ಮೂಡ್ಲೆ 18, 180 meters per second. Correct? Yes, correct. What about others? Solution ಅರ್ಥ ಆಯ್ತಾ? ಅನ್ವಿತಾ, ಜ್ಯೋತಿ, ಮಣಿಕಂಠ, ನಾಗಿನಿ, ನೇತ್ರಾವತಿ. Next, who is there? No. Priyanka. Yes, okay. So copy down. If you have copied down, I'll go for the next question. Okay, the next question is I'll clear it. Okay, 180 ಬರುತ್ತೆ. Option D is the correct answer. The next question is, a system of two capacitors of capacitance 2 microfarad and 4 microfarad is connected in series across a potential difference of 6 volt. The electric charge and the electric energy stored in the systems are. So they are giving you two capacitance value 2 microfarad and 4 microfarad connected in series ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಅದರ ಮಧ್ಯದಲ್ಲಿ potential difference ಕೊಟ್ಟಿದ್ದಾರೆ. The electric charge and the energy stored we need to calculate. So little bit quite simple question. So in series combination, the capacitance of the capacitor is given by C1 into C2 upon C1 plus C2. So what is C1 into C2? So C1 into C2 is nothing but what? 2 into 4 upon 2 plus 4. Correct? Huh? So 4 2s are 8 divided by 6. So 8 by 6, 8 by 6 is nothing but what? 3s are 4s are. That is 4 divided by 3 microfarad. 4 by 3 microfarad. So potential ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ? 6 volt ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. The electric charge ಅಂದ್ರೆ Q ಬೇಕಾಗಿದೆ. So Q is equal to what is the formula? C into V. So C ಎಷ್ಟಿದೆ? 4 by 3. V ಎಷ್ಟು ಬಂದಿದೆ? 6 ಬಂದಿದೆ. So 3 1 3 2s are 6. 4 8. That is 8 microcoulomb. Because the capacitance is given in micro, so therefore it is microcoulomb ಬರುತ್ತೆ ಇಲ್ಲಿ. Next, energy stored. The energy stored is given by 8 microcoulomb. ಒಂದೇ ಆಪ್ಷನ್ ಇದೆ, ಆಪ್ಷನ್ ಬಿ ಅಷ್ಟೇ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. ಸೊ ಫಸ್ಟ್ ಒನ್ ಎ 1 ಅಂತಿದೆ, ಸಿ 10 ಅಂತಿದೆ, 36 ಅಂತಿದೆ. therefore directly ನಾವೀಗ ಬಿ ಅಂತ ಮಾರ್ಕ್ ಮಾಡಬಹುದು. ಇಲ್ಲ ಕನ್ಫರ್ಮೇಶನ್ ಬೇಕಾದ್ರೆ ನೀವು ಎನರ್ಜಿ ಕೂಡ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಹಾಫ್ ಸಿ ವಿ ಸ್ಕ್ವೇರ್ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್ ಸಿ ವಿ. ಸೊ ಸಿ ವ್ಯಾಲ್ಯೂ 4 by 3 e square. So v is 6. So 6 square. Before microjoule. So option B is correct. Check ಮಾಡಿ ಯಾರಾದ್ರೂ ಇದ್ರೆ ನೀವು ಕೇಳಬಹುದು. Copy down. We can go for the next question. Option B ಆಯ್ತಾ? Then the next question is, 2 point charges A is equal to plus 3 nanocoulomb, B is equal to plus 1 nanocoulomb are placed 5 centimeter apart in air. The work done to move a charge B towards A by 1 centimeter is. Yes. So here we have the 2 point charges is having 3 nanocoulomb and the other one is just 1 nanocoulomb. They are placed 5 centimeter apart. They are placed 5 centimeter apart in air. The work done to move a charge B. ಸೊ ಬಿ ಇಂದ ಎ ನಾವು ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ by 1 centimeter. Just 1 centimeter move ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Then what is the work done in doing so ಅಂತ ಕೇಳಿದ್ರೆ, therefore solution ನೋಡಿ, work done is equal to change in potential energy. Work done is equal to change in potential energy. So this is equal to UF minus UI. Correct. So final energy, final potential energy is given by what? So it is electrostatic potential energy. Aita potential energy andre ನೀವು mgh ಅಂತ ತಿಳ್ಕೊಬೇಡಿ. It is electrostatic potential energy. So the expression is what? K Q1 into Q2 divided by RF ಅಥವಾ R2 minus K Q1 into Q2 divided by R1. Okay, simplify ಮಾಡ್ತೀರಾ? What is 1 K ಅಂದ್ರೆ 1/4 pi epsilon naught ಅಂದ್ರೆ 9 into 10⁻⁹. Q1 Q2 3 ಮತ್ತೆ 1 nanocoulomb ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. You can take it as a common. So inside the bracket R2 minus R1. So R2 minus R1. So R2 is 4 ಯಾಕಂದ್ರೆ 5 minus 1 ಆಗುತ್ತೆ. Next R1 5 ಆಗುತ್ತೆ. ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ, ನಾನು ಇಲ್ಲಿ ಜಸ್ಟ್ ಸ್ಟೆಪ್ಸ್ ಬರಿತೀನಿ. ಕಾಮನ್ ಆಗಿ 1/4 pi epsilon naught, that is 9 into 10⁻⁹ into Q1 3 into 10⁻⁹ into Q2 1 into 10⁻⁹ bracket ಒಳಗಡೆ 1/R2. So 1/R2 1 centimeter. So 5 ಇಂದ ಈ ಕಡೆ 1 centimeter ಬರ್ತಿದೆ. So it is 4 into 10⁻² minus 1 divided by 5 into 10⁻². So simplify ಮಾಡಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ಚೆಕ್ ಮಾಡಿ. You have the options in front of you. You just solve it 1 minute ago. This is the answer. B. Why so much confusion? Yes. The correct answer is, that is 1.35 into 10⁻⁷. Okay. I hope everyone is agreeing with the solution so that we can go for the next question. B is correct. 29. It's the minimum value of effective capacitance that can be obtained by combining three capacitors of capacitance 1 picofarad, 2 picofarad and 4 picofarad is. So what they're asking, Nodi, the minimum value of effective capacitance that can be obtained by combining three capacitors of capacitance 3, 2 ಮತ್ತೆ 4. So ನಿಮಗೆ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಬೇಕಾಗಿದೆ. ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಯಾವಾಗ ಬರುತ್ತೆ? ಪ್ಯಾರಲಲ್ ಇದ್ದಾಗ ಬರುತ್ತಾ, ಸೀರೀಸ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಬರುತ್ತಾ ಫಾರ್ ಕೆಪಾಸಿಟರ್ಸ್? ಎಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸಿ ಪ್ಯಾರಲಲ್ ಇದ್ದಾಗ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಆಡ್ ಆಗುತ್ತೆ, ಹೌದಾ? 1 + 2 + 4 7 ಬರುತ್ತೆ ಅವಾಗ. ಸೊ ದಟ್ ಇಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್. ಸೊ ನೀವು ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಯು ವಿಲ್ ಗೆಟ್ ದ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ, ಹೌದಲ್ಲ? ಸೊ ಈಗ ನೀವೇನ್ ಮಾಡಿ, ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಪ್ರಕಾರ ಅವ್ರೇನು ಆನ್ಸರ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಚೆಕ್ ಮಾಡಿ. ನಿಮಗೆ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಬೇಕಾಗಿದೆ ಅಂದ್ರೆ ನೀವು ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಇನ್ ಕೇಸ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಬಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಥರ್ಡ್ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಸೊ 1/C is equal to 1/1 + 1/2 + 1/4. ಎಲ್ಲ ಪಿಕೋ ಇರೋದ್ರಿಂದ ನಾನೇನ್ ಯೂನಿಟ್ ತಗೊಂತಾ ಇಲ್ಲ ಪಿಕೋ ಫ್ಯಾರಡ್ದು. ಸೊ ವಾಟ್ ಇಸ್ 1/1 + 1/2 + 1/4? So LCM is 4. So here it is 4s are 2s are 1s are. That is 4 + 2 + 1. That is nothing but 7 divided by 4 picofarad. But ಇದೇನಿದೆ 1/C ಇದೆ, ನಮಗೆ C ಬೇಕಾಗಿದೆ. Therefore it will be 4/7 picofarad. So ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ, here 7/4 is also given, 4/7 is also given. ಸೊ ನೀವು ಇಲ್ಲಿ ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಳ್ಳಿಲ್ಲ ಅಂದ್ರೆ ಆಪ್ಷನ್ ಎ ಅಂತ ಮಾರ್ಕ್ ಮಾಡ್ತೀರಾ, ಅದು ರಾಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ 4/7. ಓಕೆ, ಸೊ ಟು ಹ್ಯಾವ್ ದ ಮಿನಿಮಮ್ we need to take the series combination. To have the maximum we need to go for the parallel combination in case of capacitor. Okay, I hope you have copied down this. Next question. A mass of 1 kg carrying a charge of 2 coulomb is accelerated through a potential of 1 volt. The velocity acquired by it is. Yes, we need to calculate the velocity of mass 1 kg and a charge of 2 coulomb, and it is having a potential of 1 volt. Will you do it? So when they are saying that it is moving, so what we need to do here, we need to equate again two energies. So yaವಾಗ ಈ ತರ questions ಬರುತ್ತೆ, we need to equate the equations, then we need to calculate. So it is half mv² why the body is in motion. Then when it is acquiring a potential of 1 volt, it is moving through a potential of 1 volt, therefore half mv² is equal to qv ಅಂತ ಆಗುತ್ತೆ. ನಮ್ಗೆ ಏನ್ ಬೇಕಾಗಿದೆ, ವೆಲಾಸಿಟಿ v. ಸೊ ನಿಮ್ಗೆ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬೋದು, ಇದು ಪೊಟೆನ್ಶಿಯಲ್ ಆಯ್ತಾ, ಇದು ಪೊಟೆನ್ಶಿಯಲ್, this is your potential, and velocity is this one, this is your velocity. Okay, so simplify it for v. I'll simplify and I'll tell you. V is equal to q v 2 upon m, but it is v square, therefore v is equal to 2 qv upon m ಆಗುತ್ತೆ. ಸೊ ನಿಮ್ಮ ಹತ್ರ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಇದೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, ಟೆಲ್ ಮಿ ದ ಆನ್ಸರ್ಸ್. Yes, Jyoti, A or B, it is Priyanka, Anvita, correct, it is B. Yes, Jyoti, check with your answer. Root 2 ಬರಲ್ಲ, 2 ಅಷ್ಟೇ ಬರುತ್ತೆ. So 2 into 2 into 1, 2 into 2 is 4, 4 square root 2 ಬರುತ್ತೆ, ಸಿಂಪಲ್. So option B, ಹೌದಲ್ಲ? I hope everyone is getting. So simplification ಅಷ್ಟೇ ಮಾಡಬೇಡಿ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಯಾವ ತರ ಸಾಲ್ವ್ ಮಾಡೋದಂತ, ಬಿಕಾಸ್ ಯು ನೀಡ್ ಟು ಆನ್ಸರ್ ದ ಎಕ್ಸಾಮ್. ಹೌದಲ್ಲ? ಸೊ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬೇಕು ಯಾವ ತರ ಮಾಡ್ಬೇಕಂತ. Let us go for the next question. The work done to move a charge on an equipotential surface is. So equipotential surface ಮೇಲೆ work done ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. So let us calculate what is the work done for the equipotential surface. So that is infinity, less than 1, greater than 1, or it is 0. Actually, we will study this in the theory part. Anybody knows? So Sangeeta is giving answer option D. Yes, Priyanka, Jyoti, others, Manikanta. Nagini, Netravati. Option D correct agide. That is in theory. Properties of equipotential surfaces anna study madbekadre we will study this. Haudalla? That is the work done on an equipotential surface is 0 anta navalli statement alle ಹೇಳ್ತೀವಿ. So option D is the correct answer. So no need to prove this one. Directly we can understand it is option D. Let us go for the next question. Another few questions we have. Two metal plates are separated by 2 centimeters. The potential of the plates are minus 10 volt and plus 30 volt. The electric field between the two plates is. Yes. That is, we have the two metal plates which are separated by 2 centimeters. The distance between them is 2 centimeters. So distance anna centimeter idudana meter al ಮಾಡ್ಕೊಳ್ಳೋಣ. Next, the potential between the plates is minus 10 volt plus 30 volt. Minus 10 volt and minus 30 volt plus 30 volt. What is the electric field? So electric field we need to calculate. So ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ the electric and the potential ಏನಂತ ಕೊಡ್ತೀವಿ? The electric field is equal to minus dV by dr ಅಂತ ಹೇಳ್ತಾರೆ. So minus dV by dr ಅಂದ್ರೆ dr ಅಂದ್ರೆ ಇದು ಡಿಸ್ಟೆನ್ಸ್ ಆಗುತ್ತೆ, dV ಅಂದ್ರೆ ಪೊಟೆನ್ಶಿಯಲ್ ಆಗುತ್ತೆ. ಸೊ ಮೈನಸ್ ಆಲ್ರೆಡಿ ಮೈನಸ್ ಇದೆ ನಮ್ಮ ಹತ್ರ ಇಕ್ವೇಶನ್ ಅಲ್ಲಿ minus 10 plus 30. That is nothing but so minus into minus it be 40. ಹೌದಲ್ಲ? So here we can directly write the value because potential ಎರಡು values ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು ಇಲ್ಲಿ minus 10 ಮತ್ತೆ 30 ಅಂತ. Therefore here it will be 40 divided by the distance is 2 into 10 raised to minus 2. So 2 ones are 2 twos are. It is 20 into 10 raised to plus 2. So 20 into 10 raised to plus 2 is nothing but what it is 2000. Correct? Option A. Okay. I hope it is clear. Thousand minus if I keep it out and if I write 30 minus 10 I multiply this minus 30 plus 10. Okay, 20 ಆ ತರ. Okay, okay. Then it will be option D. Yes. So we can this option D, because here minus is there. We need to multiply inside the bracket. So multiply inside the bracket. It will be. ಮತ್ತೆ ಯಾವ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಟಿಲ್ಲ ಅಲ್ಲ ಅವರಿಗೆ. Okay, okay. So then it is option D, 1000, not option A. Option D ಬರುತ್ತೆ, because minus we need to multiply it inside. Equation ಅಲ್ಲಿ minus dv by dr ಅಂತ ಇದೆ. ನಮ್ಮ ಕ್ವಶನ್ ಅಲ್ಲಿ 30 minus 10. So 30 minus 10 is minus plus 20. So plus 20 it is. Therefore 20 divided by 2, 10. 10 into 10 raised to 2, it is 1000. So option D is the correct answer. Yes, Priyanka, option D correct. Next question. Yes, the next question is, a particle of mass m, charge q, is placed at rest uniform in a uniform electric field and then released. Then the kinetic energy attained by the particle after moving a distance of y is. I'm feeling we have solved this exam. See, or else there we might have followed different step. Here we can go for work done is equal to force into displacement. So force is equal to, according to electric field definition, QE anta baribodu. Displacement ಇಲ್ಲಿ y ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, and this work done we can take it as energy stored, that is kinetic energy. So option A. Actually ಇದನ್ನ ನಾವು ಮಾಡಿದ್ವಿ ಫಸ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇನೆ ಮಾಡಿದ್ವಿ, actually ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ. So option A, ಅಲ್ಲಿ ಮೇ ಬಿ ಸ್ವಲ್ಪ ಡಿಫರೆಂಟ್ ಸ್ಟೆಪ್ಸ್ ಅನ್ನು ಫಾಲೋ ಮಾಡಿದ್ವಿ. You can go for this step also. Option A is correct. Next question. A dipole of dipole moment P and moment of inertia I is placed in a uniform electric field E. If it is displaced slightly from its stable equilibrium position, the period of revolution of the time period is. Yes, we need to calculate the time period here. But they are giving to calculate the time period. We have the dipole moment, electric field, ಆ ತರ ಕೊಟ್ಟಿದ್ದಾರೆ. So ನಮ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಗೊತ್ತಿದೆ, that is time period is equal to, it is 2 pi under root of moment of inertia I divided by tau. Tau is the torque here, right? So I upon tau, this is the formula for the time period here. ಆದ್ರೆ ಅವ್ರ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಎಲ್ಲಿ ಟು ಮತ್ತೆ ಐ ಎಲ್ ಕೊಟ್ಟಿಲ್ಲ, ಅವರು ಪಿ ಇ ದಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಬಟ್ ವಿ ಆಲ್ಸೋ ನೋ ದಟ್ ಟೋ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಸೊ ಟೋ ಇಸ್ ಈಕ್ವಲ್ ಟು ನೆನಪಿದೆ, ದಟ್ ಇಸ್ ಟಾರ್ಕ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ವಿ ವಿಲ್ ರೈಟ್ ಇಟ್ ಎಸ್ ಪಿ ಡಾಟ್ ಇ ಅಂತ ಬರೀತೀವಿ, ನೆನಪಿದ್ಯಾ? ಸೊ ಪಿ ಡಾಟ್ ಪಿ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್, ಪಿ ಇ ಸೈನ್ ಥೀಟಾ ಅಂತ ಹೇಳ್ತಾರೆ. I hope you remember this. So therefore this time period is equal to 2 pi under root of I divided by PE. I divided by PE. Option which one? D. Yes, so option D is the correct answer. Next, another last two questions we will see. Okay, see here. That is in figure. Charge on a capacitor is plotted against potential difference across the capacitor. The capacitance and energy stored in the capacitor are respectively. So you can see the figure here. The charge is along the y-axis and the potential is along the x-axis. So what they are asking, the capacitance and the energy stored in the capacitors. So let us see what we will here. So graph very simple question it is. So from the graph, the slope is given by, your slope is nothing but what, y-axis by x-axis. So y-axis by x-axis y-axis is charge upon x-axis is voltage. So what is q by v? So q by v it is nothing but the capacitance C. So therefore from the slope we can write C is equal to q by v, which is equal to, so q is 120 and v is 10. So this will get cancelled. It is 12 microfarad. It is 12 microfarad. This is what the capacitance value, but 12 microfarad irodu 2 ಇದೆ ನಮ್ಮ ಹತ್ರ. So let us see what about the energy. So energy is equal to, so it is half qv. I'll take the formula. So 1 by 2 q value. So q value is how much? It is 120 into v value. It is 10. So 2 ones are 12 into 5, it is 60. So it is 600 microjoule. So it is option B. Correct? Understanding? So option B is the correct option. I hope you have copied down this. I'll go for next question. The electric field and the potential of an dipole vary with the distance r respectively as. So the electric field and the potential for the expression that is the electric field expression due to the dipole in baratte, it is 1 upon 4 pi epsilon naught 2p upon r cube baratte, and the potential due to the dipole, it is 1 upon 4 pi epsilon naught p divided by r square anta baratte. So from the expression you can just tell it by yourself. It is option B, B or C. Yes, it is C. Correct. So from the expression you can tell the answer, that is option C. Electric field is inversely proportional to the Q, then the potential is inversely proportional to the square. Okay. The last question for the today's class as well as for this electric field and the capacitor, electric potential and the capacitor. Next class, current electricity on Friday. Yes. See, two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges is. Yes. So we have the two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb. They are located 40 centimeter apart. Well, consider here one charge is there, here one charge is there. So they are 40 centimeter apart and the center in the, this is at a 20 centimeter and the 0.20 meter. So this is also from the center, it is 0.20 meter. So this is electric field is along this direction and it is along this direction, E1 and E2. This Q1 and this is Q2. Okay. Now the distance between the two spheres is, 40 centimeter. This is equal to 0.4 meter anta agutte. So midpoint alli estagutte nodi. So from the midpoint the distance will become R1 is equal to R2 is equal to, it is 0.4 upon 2 estagutte, it is 0.2 meter anta agutte. ಅವ್ರು ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, the potential at the midpoint ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು, at the center O. So at the center O, the potential is given by V is equal to 1 upon 4 pi epsilon naught Q1 by R1 plus Q2 divided by R2. So you know the value, substitute, simplify, answer baratte. So 1 upon 4 pi epsilon naught, 9 into 10 raised to 9. Q1, Q2. So 10 raised to minus 6 micro andidare. So it will be common. R1, R2 value same irodrinda ನಾನು ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, 1.8 plus 2.8 bracket complete 10 raised to minus 6, this whole divided by R1, R2. So the value is 0.2. So simplify, check the answer. Yes, students, what is the answer? You should get option D. Check ಮಾಡಿ, D ಬರುತ್ತಾ ಇಲ್ಲ ಅಂತ check ಮಾಡಿ. Okay. So check it whether it is right or no. Option D 2.1 into 10 raised to 5. You should get option D. Just check it. Okay. I hope you have copied down this. In the next class, we will start with current electricity. So idral option D ಬರುತ್ತಾ ಇಲ್ಲ ಅಂತ check ಮಾಡಿ. And let me know, college ಅಲ್ಲಿ start ಆಗಿದೆಯಾ current electricity? Because according to that synopsis plan. ಈ lessons ಕೆಲವೊಂದು college ಅಲ್ಲಿ start ಆಗಿತ್ತು, start ಆಗಿರ್ಲಿಲ್ಲ. What about current electricity? No. Maximum maybe in start ಆಗಿರ್ಲಿಕ್ಕಿಲ್ಲ ಅಂತ ಅನ್ಕೊಂತೀನಿ. Yes. Then we will go little slow only for the current electricity. Okay, students. Yes. So option D. Check it out. In the next class, we will start with a new lesson. Thank you.